The non-inverting amplifier has a flipped orientation of the op-amp from usual, where the plus is at the top instead of the minus. Note that for the purposes of circuit analysis, the plus itself means little. In the real world, I believe the negative terminal is where you want all of your feedback loops to occur, while the positive terminal is you don't connect to any feedback loops. In the non-inverting amplifier, you connect a voltage source directly to the positive terminal. And just like in the inverting amplifier, you have feedback between the output of the op-amp and the negative terminal of the op-amp through resistor final. But resistor initial is connected not only to the negative terminal, as in the other circuit, but to the ground. This changes the analysis of the circuit. The equation for VO is 1 plus RF over RI times V initial. Notice the lack of negative sign. There is no inversion or turning negative of the voltage in this circuit. Let's analyze this circuit using the fundamental principles of op-amps to determine that this equation is true. First, the voltage assumption. These two voltages are the same, so what is the voltage at this point? It is VI. Thus, we can determine the current across the resistor. We shall call it I and set it equal to VI over RI. This is par for the course from the previous version of the op-amp. Now let's use the fundamental current assumption. Given that these currents are zero, what is the current across RF? The current across RF can be said to also be I, which equals VI over RI. What is the corresponding voltage drop? Well, that is simply I times R, which is going to be VI over RI times RF, or RF over RI times VI. Now, what is the voltage at this point? It is VI plus this voltage drop, because in this direction it's a rise, and so this voltage is VI plus RF over RI times VI, which is equal to VI times 1 plus RF over RI, and that corresponds to the voltage we saw above. It's interesting to note that in this circuit, we plug a voltage source into the positive terminal, and in this very interesting circuit, we plug in a voltage source into both the positive terminal and the negative terminal. They just make things more complicated, basically. But these fundamental amplifiers have basic, easy rules that you can always apply if you use the op-amps in these ways. Another thing you will learn to do soon is cascade amplifiers together. P-Stan will be teaching you about the other two useful forms of amplifiers as well, and he may use a different method of analysis to prove these rules, so hopefully you'll learn more things.